Hi everyone, let's discuss today's lead code problem. So the problem is quite simple. You are given a string and you need to return the number of subsequence that are of length 3 and are palindrome and unique. So a given string s, you're given the string s, you need to return the unique palindrome of length 3. ठीक है, length 3 that are a subsequence of s. So simply we need to find a subsequence of length 3 and if it is a palindrome and if it is a palindrome then we need to return the number of unique palindrome number of unique palindromes. Okay, so our first priority here is key for the given string. If you don't know about what is a subsequence and what is a palindrome we are talking about, so basically a subsequence is a string. A subsequence of a string is a new string generated from the original string with some characters deleted without changing the relative order. Matlab, if we are given a b c d, then the subsequence can be, we can take a, we can take b. Let's suppose we want to skip c, we can skip c. Another case would be कि if we want to take A and we don't want to take any B and C, we can definitely take B. So for every element, we have a choice to include it into a subsequence and not. So if we consider a string of length 4, then our total subsequence are 2 raised to power 4. That is basically 16. Okay. Okay. So our first requirement is for the given string, I need to find all the subsequence. How can I find all the subsequence? There are two methods. First is using recursion and the second is using bit manipulation. And both the methods require 2 raised to power n of time complexity, order of 2 raised to power n time complexity, to basically find all the subsequences of the given string. And if we find the number of subsequences of length 3, because we'll stop our what we can say making of subsequence at the length of 3, if the maximum length of our required subsequence can be only up to 3, then we can check if this is a palindrome. Yeah, if this is a palindrome, then to maintain the unique list we can make use of a set here. So what we can do, that is basically our brute force approach. uh, One second. What is our brute force approach? We would be using recursion to find all the subsequence. Then if we find all the subsequence, instead of finding all the subsequence, what we can do, we will stop our traversal, or what we can say, the search, stop our recursion when subsequence length is 3. Okay. Now, if the length is 3, we gonna check if it is a palindrome or not. If the subsequence is a palindrome, we gonna push it into a set, and after that we gonna return the size of set. Okay. So this particular approach requires the time complexity of order of 2 raised to power n to basically, in the worst case, to find all the subsequence. Then if we have a subsequence of length n plus n to find the palindrome, and if we are pushing pushing into a set, sorry, if we are pushing into a set, it would be requiring a time complexity of constant, and yeah, the overall time complexity would be 2 raised to power n, and the space complexity would be, we would be using a set order of n at order of 2n at worst case, at worst case. Okay, now if we look at its code, let's look at its code. Second. Okay, so this is our main function, uh, from which our code will be executed. So count palindromic subsequence, it will be pass the parameter as string. So I have initialized two variables. We don't वैसे need to initialize the variable, but okay, we just need to return the size of answer. Then what we can do, we would be having a recursive function that would be accepting our string and a temporary string, so that at for every character we have a choice to include it and to not include it. That's why I have passed this temporary string builder. If the temporary string size, that our subsequent size, is 3, we're gonna check if it is a palindrome or not. If it is a palindrome and it is not in our answer set, this answer set, that means it is unique. We'll add it and we'll increase our count. Okay, and after that we'll return from here because we don't need to traverse further. After that, if a number of options or the number of characters that are in the string are left to be 0, we would return from here. Otherwise, for every particular character in the string, we would be having a choice to add it. So the first recursive function is not adding it, adding the particular character in the subsequence. And the second part, that is from temp str.append, will we will be adding that particular character and making a recursive call, so that we would do the recursion for all the remaining characters. And after that, because we will be using this particular temporary string to make uh, changes changes to the another strings, so we would be deleting this particular after this particular recursive call. Okay, now this would be requiring us, so as you can see, it is giving us that limit exceed error, because it will be requiring us the time complexity of 2 raised to power n. So the better approach of this is using a prefix and suffix array. So what's the concept of prefix and suffix array? So the prefix, we just, because we only need 3 length subsequence, and that we need to check if it is a palindrome or not. So if we are at a current index A, we just need to check if the character previous to it and the character that is basically the suffix of it, if these are equal, then we would be having a palindromic subsequence. Okay, so is there any method we can do it to maintain this particular pattern? So what we can do, using suffix and prefix array, we can calculate the number of characters or the number of specific characters that are prior to this particular character using prefix array, and the number of characters that are after that particular character using the suffix array. So how we will be doing it? Let's understand it with a test case, a. So I would be maintaining a suffix and a prefix array that would be of size 26. So basically we need to calculate the number of characters that are basically lower cases from 0 to 26. So index would be 25. It would be our prefix array and this would be our suffix array. You would got this particular algorithm in a one go. Okay. So before basically checking key what all characters are to maintain this key, if this particular character is previously existing in the string or not, if this particular character is previously existing in the string or not, what we can do, we can first find the count of each character using the suffix array. So what we'll do, so the A would be represented by 0, it would be 3, B would be represented by 1, it would be 1, C would be represented by 2, it would be 1. Okay. So if we are at a particular character A, B, C, A, all of them would be 0. Okay. If I am at a particular character, I would decrement one count from the suffix because this is not what we can say, because we need to find the number of elements that are after it using suffix. So if I am at a particular character, it will not be after it. So once I am at a particular character, I would first decrement its count by 1. Then I would check to maintain this particular pattern. Is there any element that is existing previous to A? No, there's not an element. And how can we check it? Using prefix. So I will loop over the prefix key. Is there any element that is existing previous to A? No, there is not. Okay. That is, we cannot make a subsequence using only A. Then what we'll need to do after, before moving to the next character, I would increment its prefix count by 1. Okay. I am at A. I would check key what all elements are previous to this A. So I've encountered a A. So before that, if I'm at a particular character, I would decrement its suffix count by 1. So it would be 1. Then I would check if there are any elements that are existing prior to A. Yeah, I have found A. Then using the suffix array, I would found key if there is A existing after this particular element. Yeah, there is A existing after this particular array. So one of my subsequence would be AAA. Okay. Then I would put this particular subsequence in my set to maintain the unique palindrome. Okay. Then before moving to the next character, the suffix of A would be increment by 1. I'm at B. Every time I visit a character, I decrement its suffix by 1. It would be 0. So I am at B. I'll check the characters that exist prior to B. Is it A? I'll check if there is any A that is existing after B. Yeah, it is. Then ABA would be one of my palindrome. I would put it into the set. And before moving to the next character, I would increase its prefix by 1. Okay. The next character is C. Every time I visit a next character, I would decrement its suffix by 1. So for C, I would check the element that are existing previous to C. I have I have A. Is there any A in the suffix? Yeah, it is. So ACA. would be my, what we can say, a subsequence. Then there is also a B. So C, B that is existing previous to C. I would check for the suffix of B. There's none, so it cannot be put into the set. Okay. And there is no other previous character that is existing. So I'll move to the next. Before moving to the next, I'll increment its prefix by 1. I am at A. Okay. Every time I am at a particular character, I decrement its suffix by 1. It would be 0. So at A, what are the previous elements to the A? It is A, B, C. Okay. First I'll check A. So is there any element that exists after this particular A? No. That is basically A. No. The prior to A we have B. Is there any element B after this particular A? No. Okay. There is also C that is occurring. Is there any element that is existing to the after A? No, there is not. So we don't put anything into the set. And now the traversal of the string is over. We can see the palindrome, the subsequences in our set are 3. We just need to return its size as 3. Okay. So our algorithm is basically we find the count of each character. Okay. And initially we would be using suffix for it. Now suffix is to basically manage the characters, or manage, I'm saying it would be the count of characters after current character. In the prefix array would be having count of characters before current character. Okay. And we try to maintain this. If this C is my current character, then XCX pattern. Okay. Then for a particular character, if I'm at a particular character, if I am at particular character, first thing I will do, suffix of that character would be reduced by 1. The second thing, I would check in the prefix and suffix for all the characters. If both exist in suffix and exist in prefix and suffix, then we have found our subsequence. Okay. After that, we would put the subsequence in set. Okay. Now, if this is our algorithm, let's try to apply it for these two test cases also. So the string is A, D, C. Okay. The suffix would be 0, 1, 2, 3 up to 25. 1, 1, 1, 0. All will be 0 initially. In the prefix, all would be 0 from 0 to 25. Okay, let's start. Okay, A, D, C. I'm at A. सबसे पहले I would decrement our suffix by 1. It would be 0. I would check कि if there are any elements that are existing prior to A. There are none. Okay. Before moving to the next character, I would increment my prefix of that particular character by 1. I'm at D. घटा दो. The suffix at suffix of the character D would be decremented by 1. It would be 0. Then I would check कि any element that is existing prior to D. Yeah, we have A. So A. Is there any A after it? No, there's not. Bad luck. So before moving to the next character, what we'll do? Increment our prefix. We are at C. Decrement it. C. Is there any element prior to C? Yeah, we have two. C and D. Oh, A and D. Okay, A. Try to find A after C. None. Then we have D. Try to find D after C. None. Okay. So before moving to the next character, I would increment prefix by 1. And if I visit next character, that means there are none characters left. We have nothing in our set. Bad luck. So we cannot found any subsequence that is a palindrome of length 3. Now, this is an interesting test case. Example 3. B B C B A B A. Okay. 0 1 2. इससे काम चल जाएगा. It would be a suffix. Then we would be having a prefix 0 1 2 up to 25. All will be 0. Suffix initially what we'll do, we'll increment their count. So we are having 4 B's, 2 A's and 1 C. All of them would be 0. So if I try to traverse this particular string, we have found B. The first rule is decrement the suffix by 1. I am at B. Try to find any element that is existing previous to B. None found. Okay. Before moving to the next character, increment its prefix. Okay. Now I am at B. Decrement its suffix. If I am at B, try to find any element that is existing prior to B. Yeah, we have B. Is there any element after B? Yeah, we have B. Okay. Then we have found a subsequence that is palindrome. BBB. Put it into the set. Now move to the next, but don't forget your responsibility to increment the prefix of that particular character. It would be 2. Now we have C. Decrement the suffix. It would be 0. If I am at C, prior to it are B. Is there any B to its right? Yeah, we have 2. काम बन गया BCB. We would put it into the set. Okay. So before moving to the next, we would increment our prefix. We are at B. Decrement its suffix by 1. Try to find any elements that are previous to B, this particular B. We have B. B. Is there any B to its right? Yeah, we have a B. B, B, B. We'll put it, but this is because set contain unique values. There will always be one entry of B, B, B. Okay. We have another previous element that is C. Is there any C to the right of B? None found. Okay, bad luck. Then we move to the next. Before moving to the next, increase the prefix by 1. It would be 3. I am at A. Now, if I'm at a particular character, decrease its suffix by 1. It would be 0. Now, if it is 0, if I'm at A, I would check any previous element. Yeah, we have B. Is there any B to its right? Yeah, we have one. B, A, B. I found one. Hooray. I have also a B. Uh, I have also a C. A, C. Is there any C to its right? None found. Okay, bad luck. So I'll move to the next. Before moving to the next, I will increase my suffix by 1. Initially it would be 0. Sorry, prefix by 1. I'm at B. Okay, it would be 2, I think. It would be currently 1 because the number of A's are 2. So the traversed are 1. So I'm at B. I would decrement its count by 1. I'm at B. I try to find key. Is there any previous element? Yeah, I have found A. Is there any to its right? Yeah, I have A. Okay. A, B, A. I'll put it into the set. मजा आ गया. Then we also have B to its left. Is there any B to its right? None found. We have also C. Is there any C to its right? None found. Uh, Move to the next. We have found A. Before moving to the next, increment its prefix. It is 4. A, 0. If I am at A, I have A to its left, but I have nothing to its right. I am at A, I have found B to its left, I have nothing to its right. I am at A, I have found C to its left, I have nothing to its right. So I'll move to the next. Before moving to the next, I'll increment our prefix by 1. So if I'm all my characters of the string are over, then I have found the 4 palindromic subsequences of length 3. Are they matching? BBB, correct. BCB, correct. BAB, correct. ABA, correct. So let's code it out and then we try to find its time complexity and space complexity. Okay, let's code it out. Uh, Editorial, no, editorial, not code. Let's code it out. Okay, we'll code it step by step so that you would get pure insight of the question. So we would be having a prefix. Okay, integer array that would be of size 26. By default, all the values in the array are initialized. The default array are initialized by 0. I would be having a suffix that would be of size 26. Okay, what I'll do, I'll traverse the string. So for the characters in the string to char array, I'll make use of the suffix, and because we are considering the particular character as mapping with integer, so a would be mapped with 0. So that's why we are doing ch minus character a. After that, we would be having a set of strings that would be our map, what we can say, our subsequences, new, and we'll create its hash set implementation so that the insertion and deletion would be order of 1. After that, I would traverse the string. It would be from 0th index to n minus 1th index. And the first thing, if I am at a particular character, suffix को decrease by 1. Okay, suffix of that particular character. So char at I minus a would be decremented. Okay, then we loop over the prefix and the suffix array, and what we'll do, we try to find if prefix of I is greater than 0 and suffix of I, or what we can say, because we are using I previously. We'll name it at ch, ch here also. Prefix of this particular character, if it is greater than 0 and suffix of this particular character is greater than 0, then what we'll do, we'll make a string that is a particular subsequence sequence with basically a string that would be having a character a plus ch plus our particular character at this particular index s dot char at I plus char of a plus h. Okay, I'll make this so that typecasting would be easy. So if you are wondering why I have the double quotes added previous to this particular string, key by default it would be a character or a integer addition if I don't put this particular double quotes. Okay, to make this key, this is a particular string, that's why I'm appending the empty string. Okay, after that I would put this particular subsequence in the set of subsequences, subsequences dot add this subsequence, and if everything is done, we are basically forgetting one step. Before leaving a particular character, prefix of that particular character s dot char at I would be increased by 1. Okay, after that, for this it is over. Now we just need to return our answer, that is the subsequences size, subsequences dot size. If we have correctly implemented what we were thinking, it would work fine. So prefix array initialized to 0. We need the count of all the characters. Suffix array we are using. Then for the suffix array for the particular character, decrementing, correct. And if there are characters that exist previous to this particular character and after it, then it would definitely be forming a subsequence, a palindromic subsequence, and we are maintaining here the XCX pattern, that is correct, and we would be adding it in the subsequence that would maintain our unique. Before moving to next character, prefix में डाल दो of prefix will increase for the particular character, and will, yeah, we would return the size of subsequence. If we are correct, it would work fine, and if we try to submit, I think it would be submitted fine. Okay. Uh, okay. Now, if we try to find its time complexity, the time complexity of this would be, if we consider the size of this particular string to be, I'll first paste it, then I'll explain the time and the space complexity. If we consider this, if the size of the string is n, so the first traversal is taking us order of n time. This traversal is also taking us order of n time. And for this, because this is a constant traversal for constant length for 26. So if we consider this 26 into n, okay, we can consider this. Now, we are putting something into a hash set because it is a hash set implementation. So we not need to worry about time complexity. It would be order of 1. And yeah, we would be having a time complexity of space complexity. In the worst case, it would be order of 2n. if the size of nah, it won't be too often. Okay, because we are just be requiring be requiring the three length subsequences. So it would be something about key uh, if we consider its space complexity, if the length of the string is n, okay, and if we are considering 3 as our maximum length, what we can say 3 and n, it would be n minus 3 factorial, n minus 3 factorial, and it would be n minus 2 factorial. This would be our space complexity at the worst case, because we are just considering 3 length, so n minus 3, and it would be our uh, r would be, if we analyze it, it would be n factorial, and because we are just considering n minus 3 size array, it would be so n minus 2. Why I have written n minus 2? It would be n minus 3 factorial, then yeah, n 3 factorial. Okay, so it would be something about n square. Okay, space complexity. Okay, that is much efficient than order of 2 raised to power n. Much sufficient. 2 raised to power n. Okay, yeah. Okay, so the space complexity is n plus 26 into n, and the space complexity is order of n square. I think this is the better approach for it, because the approximate time complexity would be order of n. Okay, so this was the solution to the problem. What's the problem name? Unique length 3 palindromic subsequence. I think it is a good problem based upon prefix and suffix. What you can do from your side, try to implement unique length 5 palindromic subsequence, because it will follow the same logic. ठीक है, but a slight change would make it as unique length of 5 palindromic subsequence. Okay, so in case of any doubt, you can ask me in the comment section or on LinkedIn or Instagram, and for more further coding videos you can subscribe to the channel. Okay, let's meet tomorrow probably. Bye bye.